Hello everyone, welcome to my YouTube channel. Today you are going to learn about circular linked list. Please watch till the end of the video. If you like the content, please do like, share and subscribe to my YouTube channel. Without further delay, let's get into the video. What is circular linked list? Circular linked list is similar to single linked list or double linked list, but circular linked list also consists of two types. One is single circular linked list and the other one is doubly circular linked list. I will explain the difference between these two now, and I will also explain what is a circular linked list. So in the introduction video, as I have said, circular linked list, the last node of the circular linked list will contain the link to the head node again. So in this example, I have 4 nodes which are 10, 20, 30 and 40, and the last node is 40 here. So 40 is connected to 10 again. But in this single circular linked list will only contain the next node. There is no previous node as in the single linked list. But the only difference is the last node is connected to the head node again. Okay. So here we have only next node. The nodes are divided into two parts, the data part and the next part. I will show you here. So every node will be like this. So this is the next part which is connected to the next node. In this example, 10 is my head. Okay. And 40 is my tail. Tail is connected to head. Okay. And if I take doubly circular linked list, I will have one more part like this. And this is previous. Okay. Here I have the arrows again like this. Okay. The last node, that means the tail, the next part of tail is connected to the previous part of head, and also the previous part of head is again connected to the next part of tail. This is how circular linked list will work. Doubly circular linked list. Doubly circular linked list is nothing but the last node is connected to the head node again. But if it is a single circular linked list, it is similar to the single linked list. But the only difference is the last node is connected to head again. And the doubly circular linked list is similar to double linked list. But the only difference is the last node is connected to the head again. This is only the difference. So to implement this double circular linked list, whenever we are updating the nodes, when we are at the edge cases, like when we are updating the last node or when we are working with the first node, we have to update the tail. We have to connect this. So we have to update these two links also. That is the difference what we have to implement. So let's see the implementation part. First, we have to define the node class. In the single circular linked list, the node will contain the data and the next. In the double circular linked list, a node will contain previous, data and next. Now I am implementing single circular linked list. So I have commented down the previous. Okay, let's go into I have created the circular linked list.java class. In this class, let's define this public class circular linked list. I have two properties. One is head and the other one will be tail. I have to perform some operations inside the circular linked list class. The first operation that we're going to perform is insert at the end of the linked list. To insert at the end of the linked list, I'll create one method, public void insert, and I have to pass the data inside it. In data, inside this method, first we have to create the node to insert it. Node, new node equals to new node. We have data. Now the operation that we're gonna perform is insert at the end. To insert at the end, we'll have some scenarios. The first scenario will be maybe our linked list is already empty. So we have to check if our head is null. If our head is null, then our linked list is empty. So what we have to do, we have to make our new node as the head and the tail. So head equals to my new node, and also tail will be my new node. Now I have to link the head and the tail. So tail dot next is equals to head. After this, if this is not the case, we have some other nodes. So what I have to do, I don't have to iterate until the end of the linked list because I already know what is the end of the linked list, that is our tail. So I just have to insert my new node after the tail node and make the new node as the tail and then link it to head. Okay, that means tail dot next is equals to my new node, and I'll make tail is equals to new node. Now I will link them. Tail dot next is equals to head. After inserting, we have to display the values. So to display, I will copy this from the single linked list.java class. I'll copy this and then inside circular linked list.java, paste it here. This is another method, so I'll paste it here. This will run into an infinite loop. Let's check. Going to the main.java and I'll create circular circular linked list. List is equals to new circular linked list. List dot insert of 10. Copy and paste it. 20, 30, and it's 40. Now also display. Compile the code, run the code. It is running infinitely. What's happening? Going to the circular linked list.java class. See, our current is not equals to null. We are checking this condition. But in the circular linked list, the last node will never be null. It will be linked to head. It will be always linked to head. Only in the condition when the linked list is empty, the tail node will be equals to null. But we are checking that condition, so the loop is running infinitely. What we have to do, we'll do current dot next is not equals to head node. We'll check this condition. This will also does not give us the proper result. Let's see. So the last value is not printing down. Why it's happening? Because we are printing first and then updating. It is updated the value, but again when we check the condition, it was stopped at the before node, before the tail node. So what we can do is we can print the value here. Current dot data. Let's see if this one works. All the 4 values are inserted. Now implement delete by value. So how to implement delete by value? Let's create one method. Public void delete, and to delete by value we need to pass the value that we wanted to delete. So I am passing the key. So first thing I will do is I will check if my head is null. That means I will check if my linked list is empty. So if the linked list is empty, I just have to return. Now I will check if my head is the key that I am searching for. So if head is the key, I will check. We can't check. Head is a node. It is of type node and key is of type integer. So I have to call head dot data equals to key. I have to check this one. So if the head is key, in this also have 2 scenarios. One, it might be there will be only one head, only one node in the linked list. So if there is only one node, then that will be the tail also. So then I have to make the link now. So I have to check this condition. If that's not the case, I have many other, then I can just link it to the next one. So first I will check if the head is in this. I will inside this. I will check if my head is equals to tail. Okay. If the head is equals to tail, then what I have to do? I have to remove that. I have only one node and I have to remove that. So I will make my head equals to null, and I also make my tail is equals to null. So if the head and the tail are null, then the linked list is empty. So if this is not the case, then what I have to do? I have to, that means there are multiple nodes though. So after the head, there are some other nodes also. So I have to remove this head node and I will make the next node as the head node. Okay. So I'll just make head is equals to head dot next. Okay. I'll just simply do this. This will delete the head node. And then if the key is not in the head node, then what I have to do? I have to check the other scenarios. I have to iterate over the linked list, and when I reach the key that I am searching for, I'll delete that node and make the link to the other one. So I will take 2 nodes here. Node current, I will start it from the head, and I'll take node previous. It will be null. So I will iterate until I found the key. While current dot data is not equals to key, I have to iterate until this condition. What I have to do? I'll make my previous as the current, and I'll move my current. Current is equals to current dot next. If I come out of this loop, then Either I found the key. If I found the key also, I have two scenarios. Either I may reach at the end of the linked list. Either my current can be the tail. So if my current is tail, then I have to again link it to the head node. So I have to check that scenario. If my current equals to tail. If my current is tail, then what I have to do? I'll just have to, I'm at the tail position. So the before node will be previous. I just have to link previous to the head. So current will be removed. Previous dot next will be equals to head, okay? So the current will be removed. And then just return. If this is not the case, I have not reached the end of the linked list. It is in the middle somewhere. So I just have to remove that and make my previous link to the next one. What I'll do, previous dot next equals to my current dot next. Let's check if this one works. Go to the main.java. I will copy this. See, 30 was deleted. So let's check if I can delete the value at the tail node. 40 was deleted. So I can also, the edge cases were passed. So that's it for today. The task for you is to perform the remaining operations and also implement the doubly circular linked list. In the next videos, upcoming 5 days, we will solve one lead code problem on linked list. That's it for today. Thank you so much for watching. Have a good day.